Alright, here is our first lesson for 7th grade of the 2011 school year. Had to think about that. Alright, what we worked on today was arithmetic with whole numbers and money. And this is review, but the big idea that I wanted to get out of here was that this word right here, arithmetic, is a big scary word, but really they already know what it is. We have 4 fundamental operations with arithmetic, and at this level they are adding, subtracting, multiplying, and dividing. So that's basically what we were working with today, and obviously that's review because they've been working on that since, 3rd grade at least. So we'll just kind of dive in here. And the first thing that we needed to point out was the type of numbers that we were going to be working with. In this lesson we were working with 2 different types, counting numbers and whole numbers. Here are the 2 different sets. I told the students to tell me what set was the counting numbers, which set was the whole numbers. Well, normally when we're counting we start with 1. So these are our counting numbers, because we start with 1 and it keeps going up in the positive direction all the way up into infinity. And whole numbers, the only difference with whole numbers is that it starts with 0 instead. So the only difference between these 2 sets is that whole numbers have a 0, counting numbers do not. So that's the big idea there. Our first operation that we dealt with was addition, which I felt was the easiest one to start with. One good thing to know here, this question. When we add 2 numbers together, what is another name for the solution or the answer? Well, this terminology is going to come into big play already today and in the future. We call that the sum. So if a student sees the word sum, they know that there's going to be addition involved. So that's a big key. Now I'm not going to go through and solve these examples. These are addition examples, but the big idea is it's all in the setup. If we do 310 plus 1,323 plus 48, you just want to make sure that your place values are all lined up. So I start with the largest one, which would be this one, and then I go down. 310 would be next. We're counting. And 48. And there's your addition problem. So we have our ones column, our tens column, our hundreds, and then our thousands. And most everyone knows how to add this together. So if there was an issue, they came and talked to me about it. 575. Now we're dealing with money. $5.75, 63 cents, and then 3 cents. Now the big issue with this one, there are 2 things we need to point out. Now we have some decimals, but the other thing is that we've got dollar signs. We also have cents signs. So the first thing that they have to do is convert 3 cents into the dollar form. And I showed them that 3 cents is equal to 0.03. So once we got that, we can set up our equation just like we did with this one. So, stacking all these together, I would start 575. $0.63 and 0.03. We know that these aren't dollar amounts, these are actually cents. But now we have everything in the correct form. We can go ahead and do our addition, straight down, carry, all that good stuff. So it's all in the setup. The same is true for our subtraction. So when we subtract, if we subtract two numbers, we also get an answer, and we call that answer the difference. Alright, so if the students see anything with difference, they know they will be subtracting. So that's the big idea there. Once again, a couple examples with subtraction. It's another stacking thing. We'll put 4,932 above 315. Make sure the place values are lined up, and we go ahead and do our subtraction. Once again here, we have another money issue. We have $4 minus 15 cents. So I'm going to change $4 into its decimal form. And I'm also going to change 15 cents into its decimal form. And we'll do our subtraction. So we've got 0.15. And that's how we would set that up. Alright. Moving on. To multiplication. When we multiply two numbers together and we get that solution, we call that the product. So if a student sees the word product, they know they should be doing some multiplying. And the big thing I wanted to point out with multiplication is all the different notations that we're going to have along the year. These are all examples of different ways to multiply 4 and 5 together, with the exception of this one. This is the regular standard form 4 times 5. This also means 4 times 5 with a little dot. And if we have parentheses, that is also 4 times 5. Now, these would also be multiplications. The parentheses could have been here. That's the same thing. That's the same thing too. All of these things mean multiply. Now, let's say we have two variables, such as a and b, just sitting right next to each other. This right here means a times b. So that was one thing that we needed to point out. And just so that we could see what it looked like with the parentheses, these are just a couple examples. This one being the most important because a lot of times students forget that if we have a number and then another number inside parentheses, it means multiply. So this is one that came up quite a bit. This actually means 5 times $1.35. So we set it up, 135 times 5, and we would go ahead and do our multiplying from that point. Alright. And our last fundamental operation of arithmetic is division. 3 important words with division. We have dividend, divisor, and quotient. Now the big one is that the quotient will be the answer of a division problem. And once again, I wanted to point out some of the notation. This is the very standard dividend divided by divisor equals a quotient. So basically, one number divided by another will give you an answer. This we don't see too much at this level. This is how you would do it if you're going to do it by hand, which the students did do today. And as a math teacher, this is my favorite way to have it. This would be like, we'll do an easy one here. We add 6 over 3. This actually means 6 divided by 3, and we get 2. So, pretty basic. And there are another couple of examples. I did have one student ask me today, what is this 5? Is that $1? Is that a cent? Well, it's actually neither. I told him to think about it like Imagine you and 5 of your friends paid $7.50 for something, and now you're trying to figure out how to spread that out evenly. So this is actually $7.50 split up into 5 equal parts. So $7.50 divided by 5. The 5 does not have any symbol with it. And the last thing that we talked about today, it's something called evaluation. That's when we have some variables, but they are assigned numerical values. For instance, we're going to evaluate some expressions when x equals 2 and y equals 6. So if x plus y is our equation, we just substitute x in for x and y in for y, and we will get 2 plus 6 equals 8. So it's basically substitution. Same with subtraction. Y minus x, well, that is 6 minus 2, you get 4. Now remember that x and y next to each other, that means we are multiplying. So this is 2 times 6, you get 12. And our last one, y over x, remember this means division. So we have 6, put that over here, over 2, 3. So that is the basis of today's lesson. Pretty straightforward, pretty much review, but a couple important things to point out, especially as far as notation goes. So just keep in mind that when you see something like this, it means divide, something like this, it means multiply. Those things are going to come up in the future, and we are not going to want to forget those. So that's lesson 1. And if you are interested, I assigned from page 10 in your book, I assigned the practice set B through M and numbers 9, 15, and 24. So I want to get those done for tomorrow. All right, thank you.